this particular topic. So we'll be discussing some of the most importantly asked conceptual questions regarding the speed, velocity, average speed, average velocity, accelerations, and uniform acceleration and non-uniform acceleration situations. So coming to the today's first question, the ball is thrown vertically downwards. So he's throwing it vertically downwards with some velocity. That means initial velocity he has provided to us, which is 20 meter per second. From the top of it, it hits the ground after some time with a velocity. That is the final velocity he has provided. Height of the tower. We have got u, we have got v, we have got the acceleration. So we need to go for the height. So v square minus u square is equal to 2a, yes, general formula. Since it is all of them are in the downward direction, everyone will be negative, so no need to put down especially negative values. So that means 80 square minus 20 square is equal to 2 into acceleration due to gravity is g, and yes is the height, we need to find it out. So this will be the 1600 minus, sorry, this is 6400. So 6400 minus 400 is equal to 20 into s. So s will be equal to this is 6000 by 20. So that comes out to be the 300 meters. So this is your first option. Next one. Preeti reached the metro station. Okay, so Preeti has been traveling. She has reached the metro station and found that escalator is not working. Okay, she walked up to the stationary escalator in time t1 seconds. On other days, if she remains stationary on the moving escalator would take up in the t2 seconds. So the distance is same in this situation. The time taken by her to walk up the moving escalator. That means if she walks on a moving escalator, what will be the time taken? So distance traveled is going to be the same in motor, may be the case. That means the velocity, first velocity, if I write it, then it will be the distance traveled by time will be the t1, and with the velocity on the this one, that is on the escalator, distance here also distance will be same, but the time taken is t2 here. Now he is asking this one. So now, according to the relative velocity concept, when the Preeti is on the escalator, then the relative velocity will be the velocity of the Preeti plus velocity of the escalator. Okay, so this is your velocity of the escalator only, and this is your velocity of the Preeti. Now you can put it down. Distance in neither cases, distance will be same. That is d by t is equal to d by t1 plus d by t2. Or you can take it as an 1 by t is equal to 1 by t1 plus 1 by t2 relations. Or you can write that t is equal to t1 t2 by, this will be t1 plus t2. So option B should be next one. The velocity of the particle is being given by them. He has given the velocity v is equal to at plus, okay, bt square. A and b are the constants. The distance traveled by the body in the between the 1 to 2 seconds. Velocity can be written as, and this is dx by dt. The rate of change of displacement is equal to, this is at plus bt square. Now substitute or integrate first, then substitute apply the limits. A into t integral of within the time frame of 1 to 2 seconds, dt plus b into integral of t square into dt in a time interval of 1 to 2 seconds. Now what will be the case here? So integral of the dt will be equal to the, so this is this can be written as, and directly I'm writing it, a by 2 times of, this is t square limits 1 to 2 plus b by 3 times of, it is t cube limits 1 to 2. On substituting the limits, that is upper limit minus lower limit, we will be getting the 3a by 2 plus 7b by 2. So this should be your relationship, which it is 7b by 3. Sorry. Okay. So now this should be your first option. Next one. Two cars are there, P and Q, start from the same point in a straight line, and their positions are represented by the xpt and x of qt. So as at what time does the cars will have the same velocity? That means he's asking the velocity of the P is equal to the velocity of the Q. This happens at what time? For that one, we need to first find out the velocity of the P is how much. Differentiating this equation, which is dxp by dt. So what will be getting, sir, here? So that will be the a plus 2bt, and velocity of the q should be equal to the dq or dx of q by dt, which is written as and this is f minus 2t. So he has stated that these two are same, equate them. That means a plus 2bt is equal to f minus 2t. We need to find out the time from this relationship. So you'll be getting the t is equal to f minus a by, it is 2 times of b plus 1. Okay, so this should be our relationship f minus a by 1 plus p. So this is our option. A particle of unit mass undergoes one-dimensional motion such that velocity varies with the relation. So he has given certain relation, velocity as a function of displacement, which is beta into x to the power of minus 2n, where beta and n are constant, x is n. Position of the particle, the acceleration of the particle as a function of the x he is asking. Okay, fine. So we need to find out the acceleration of the particle. How do you get the acceleration of the particle before directly going? I would like to differentiate this one dv by dx. Differentiate the velocity with respect to the x. We'll be getting it as a minus 2n into beta into x to the power of minus 2n minus 1. We know that for a variable acceleration, a is equal to v into dv by dx. Now put down the substitute the values here to get the acceleration. So v value is beta into x to the power of minus 2n, whereas dv by dx is minus 2n into beta into x to the power of minus 2n minus 1. Now minus 2n into beta will be the beta square. Now x to the power of minus 4n minus 1. So this should be your acceleration conditions, minus 4n minus 1. So option D. Next one, a stone is falling freely. Okay, covers the distances of h1, h2, h3 in the first 5 seconds, next 5 seconds, and next 5 seconds. So he is asking the relation between them. In the sense, if I draw a diagram here like this, so let it be the situation. In the first 5 seconds, it is traveling a height h1. In the next 5 seconds, it is traveling a height h2. In the next 5 seconds, it is traveling a height h3. So time taken for every interval is going to be the t is equal to 5 seconds here, t is equal to 5 seconds here. Since it has been falling freely, initial velocity u is equal to 0. So I can write from this relation that is h1 is equal to u0. So leftover is half g t square, which is 5 square. That is 25 g by 2 will be your h1. Now I'm taking the initial velocity u to be 0 only. So I'll use the same relation s is equal to ut plus half a t square. But I'll go for the total 10 seconds for the initial. So it will be the h1 plus h2 is equal to half g into, it will be 10 square, that is, implies it's an 100 g by 2. Similarly, for the total length, that is h1 plus h2 plus h3 is equal to total time taken for all the three things to cover is 15 seconds. It will be 225 g by 2. So this is a relationship, sir. From here, if I subtract the things, that is, if I remove the h1 from the h1 plus h2, we'll be getting the h2 only. So h2 is equal to 100g by 2 minus 25g by 2. That implies 75g by 2, which can be written as an 3 times of h1. And similarly, our next thing is going to be the H3. H3 can be obtained by removing this 225, that is 225g by 2 minus of 100g by 2, and that comes out to be also as an 125 g by 2, which is equal to the 5 times of h1. So you can write this one, h1 is equal to h3 by 5, h1 is equal to h3, h2 by 3. So option D, you can go for it. Next one, the displacement x of a particle of mass m moving in a one dimension under the action of the force is related to time t. T is equal to root x plus 3. So he is asking the displacement of the particle, that is x value is how much when velocity is becoming 0. So we have to first find out the velocity, and then we have to make the velocity to be 0 at a given time, at a time interval. That time we need to substitute in the x relation. So this can be written as an root x is equal to t minus 3, or x is equal to t minus 3 whole square. Now if I differentiate this one, that is dx by dt thing, we will be getting the velocity, and that velocity is equal to 2 into t minus 3, but it has to become 0, he has mentioned. So when it will become 0, t is equal to 3 seconds, velocity will become 0. What is the displacement at that particular instant? Substitute in the relation t minus 3 whole square, t value 3, t minus 3, it is 0 meters. So this is our option B. Next, the motion of the particle along a straight line is described by the x is equal to some equation he has given, motion 8 plus it is 12t minus t cube, where x is in meters, t is in seconds, retardation of the particle when velocity is becoming 0. So first we'll find out the velocity. V is equal to dx by dt. So what is the constant differentiation? 0. 12t differentiation is 12 minus this one will be the 3t square. This has to be equal to 0. When this will be equal to 0, 3t square is equal to 12 happens. That means your t should be equal to the 2 seconds. At 2 seconds, velocity is becoming 0. At that point, he is asking the retardation. So again, double differentiation for the retardation. A is equal to dv by dt, which is equal to the minus 60. Substitute the 2 here, it will be the minus 12 meter per second square. So this is your, since he has already mentioned it as a retardation, minus sign doesn't have any significance here. So now the particle covers the half of the total distance. That this is our total distance. So for first half, that is A to B, and with the velocity of the V1, this is yes. This is also same thing with the velocity V2. Average speed he is asking, so it's a direct formula actually. V average is equal to total displacement S plus S by time. Take total time is T1 plus T2, time taken for the first half and second one. It is 2S by T can be written as an S by V1 plus this is S by V2. Take out the S common in the denominator and cancel it. You'll be getting the 2 V1 V2 by, it will be the V1 plus V2. Next one, a particle moves a distance x in a time according to the equation something x is equal to, he has mentioned that t plus 5 to the power of minus 1. The acceleration of the particle will be proportional to how much? To get the acceleration, first I'm going for the velocity, which is dx by dt. So velocity will be the t plus 5 whole to the power of minus 1 minus 1. That comes out to be the t plus 5 whole to the power of minus 2. For the acceleration, a is equal to dv by dt if I differentiate. So that comes out to be the, so here it will be the minus sign will be carried in this case. So minus 2 will come down, or minus into minus becomes 2 into t plus 5 whole to the power of minus 3. Now he is asking us to express this acceleration in terms of the velocities and all these things. Okay, so from here I can replace this one as an t plus 5 is equal to v to the power of, or 1 by 2 I can replace, or minus 1 by 2. So if I replace this here, a is equal to 2 into v to the power of minus 3 by minus, or 1 by 2, this will be cancelled. That means a is proportional to the 3 by 2 times of the velocity, or it can also be written as an proportional to the displacement to the power of, that is distance to the power of 3. So like this also you can express this one. So that means for the given option, this the given question, this will be the answer. A ball is dropped from a high-rise platform at t is equal to 0, starting from the rest. That means initial velocity u is equal to 0. After 6 seconds, another ball is dropped, and the another ball is thrown downwards from the same platform with the same speed. The two balls meet after 18 seconds. That means after the drop of the first ball, when the first ball is dropped, after 6 seconds, second ball is been dropped. That means if the first ball has traveled 18 seconds, that means second ball will be traveling only 12 seconds. So if the first ball time is 18 seconds, means second ball will be traveling only 12 seconds, because it is thrown after 6 seconds of the first ball. So if I write the equation, let us meet, they are meeting at the point called as an x. After traveling a displacement, initial velocity is 0. So it can be written as an half g t square, which is equal to the half into 10 into this will be the 18 square. Now, this is for the first ball I have written. Second ball, because they are meeting, displacement should be same, but half into 10 into, it is having some initial velocity. So that's what he is asking. So that means I need to write the ut plus half at square completely here. The second ball is having some initial velocity. So Vt plus, that should be the half into 10 into, but the time taken by the second ball to reach is only 12 seconds. It should be 12 square. Since both of them are same, since both of them are going to be same, equate them. So that is half into 10 into 18 square is equal to Vt, or V into 12 same time, plus half into 10 into 12 square. Take them to one side, that is half into 10 into, which is 18 square, minus 12 square, that is 324, minus 144 into V. So we need to just go for solving of this one. So V should be somewhere around, you will be getting 75 meter per second. So this is the condition. Next one, a bus is moving with a speed of 10 meter per second on a straight road. A scooterist wishes to take over the bus in timed 100 seconds. Okay, so if the bus is at a distance of, that is initial distance is equal to relative distance is equal to 1 kilometer from the scooterist, what will happen? So relative velocity V relative is equal to S relative displacement by time. So relative displacement is 1000 meters. He wants to cross it in 100 seconds, but both of them are traveling in the same direction. Velocity of the scooter with respect to the velocity of the bus is this one. This will be 10 times. Velocity of the scooter minus 10 is equal to 10. Velocity of the scooter is equal to 20 meter per second. If he travels with this one, Definitely, he can recache that particular bus. So now, next question: a particle starts its motion from rest under the action of the force. The distance covered in the first 10 seconds is s1, and covered in the first 20 seconds is s2. So, since initial velocity u is equal to 0, I would like to go for the equation s is equal to ut plus half at square. But for the total time I'll be taking, that means s1 is equal to half, acceleration is constant since force is constant, but the time taken is 10 square, which is equal to the 100 by 250 a s1. S2 also I'm taking from the start, so time interval I'll be going for 20 square. So that will be equal to the 400 by 2, that will be 200 a. So now what is the relationship between the S1 and the S2? The S2 can be written as an 4 times of S1. So this is a relationship between them. Next one, the distance traveled. The distance traveled by a particle from the rest, that means initial velocity u is equal to 0, moving with an acceleration of 4 by 3 meter per second in the third second. That means he is asking Sn, the distance traveled in n per second. U plus general formula I'm writing a into n minus 1 by 2. U0 acceleration is 4 by 3 and the third second 3 minus 1 by 2. So that comes out to be the 4 by 3 into 5 by 2. So which is 20 by 6 or 10 by 3 meters. This is the distance covered in the third seconds. A particle moving in a straight line with a constant acceleration here changes its velocity from the 10 to the 20 after passing through a distance. He is asking the time t. So here we do have the two unknown values, time t and as well as the acceleration. First, let me get the acceleration. V square minus u square is equal to 2as. So that will be the 400 minus 100. That is 20 square is 400. 2 into a into this is 135. So 135 2 is 270. So acceleration can be written as an 300 by 270, which comes out to be the 10 by 9 meter per second square. So since we have got the acceleration, we need the time v is equal to u plus 80. V20 is equal to 10 plus 10 by 9 into t. So this is 10 is equal to 10 by 9 into t, or time t is equal to 9 seconds. So this is the condition. So it should be in seconds. Next one. A particle is moving along the x-axis with an acceleration of the f. Instead of the standard representation, he has changed it to the f. And the equation of the force, it is a function of the time, it's a time varying acceleration. That is f is equal to f naught of 1 minus t by capital T. At t is equal to 0, velocity is also equal to 0. So that means according to the question, at t is equal to 0, velocity, that is initial velocity, will also be 0. Next, and at the instant when f is equal to 0, he is asking particle velocity. So that is when f will be 0, when f is going to become 0. That means this entire function should become 0. F naught of 1 minus t by t should become 0. From this one, the time taken where it's going to become 0 is t is equal to capital T. At this particular interval, your acceleration is becoming 0. Then what is the velocity from this acceleration? So acceleration f he has given. From this one, if I need the velocity in this case, so this can be written as an dv by dt is equal to f naught of 1 minus t by t. So now integrating it on either side, taking the dt to this other side, please, and solving v is equal to. So you will be getting f naught into t minus f naught t square by 2t, or this comes out to be the half into f naught into t. So this is a relation for the velocity situation. Next one, a car moves from x to y with the speed of vu and returns to x, I suppose, returns to y with the speed. That means it is traveling from x to y and returning from y to x like this. Then the displacement is same. Since the displacements are same, then the v average can be written as an 2 times of v1 v2 by that will be v1 plus v2. So that is vu into vd. This is our thing. Next one, the position x of the particle with respect to the time t along the x-axis is given by x is equal to 9t square minus t cube. He has provided where x is in meters. Find the position of the particle when it achieves maximum speed. That means when velocity reaches the maximum, at that instant x value is how much? For that one, we need to find velocity first. So v is equal to dv by dx by dt. So that comes out to be the 18t minus 3t square. This is the velocity. For maximum velocity, for maximum velocity, first differentiation of the velocity should be equal to 0. So that comes out to be your 18 minus 60 is equal to 0 means t is equal to 3 seconds. So when t is equal to 3 seconds, we need to find out the x value. So x is equal to 9 into 3 square minus 3 to the power of 3. So that will be equal to the 9 into 9, 81 minus 27. That will be equal to the 54 meters. So this is our condition. Next one, two bodies, A and B. A bodies of mass 1 kg and this one is 3 kg. So dropping from a height of 16 meters and 25 meters respectively. The ratio of the time taken to reach the ground. Time taken does not depend upon the mass. It is root over 2h by g formula. From this one, time taken t1 by t2, 2 and g are the constant. The leftover term is only h1 by h2. That comes out to be the 16 by 25. In the sense 4 by 5. This should be a ratio. Next, the particle moves along a straight line OX. So a particle is there which is moving along a straight line OX. Time t and the distance x of the particle is given by the sum x is equal to this is 40 plus 12t minus t cube. How long the particle before comes to rest? That means he is asking what is the distance traveled by the particle before it is coming to the rest. Initially at t is equal to 0 only, the particle is at x is equal to 40 meters. So initially the particle is not at the origin, it is located at 40 meters. Now when I differentiate for the velocity, v is equal to dx by dt, then this will be turning out as an that is 12 minus, so 3t square is equal to 0. So velocity has to become 0, we need to find out the time. So from here, this is 3t square is equal to 12 means t square is equal to 4 or t is equal to 2 seconds. So at this time, what is the x value? X at the 2 seconds, this is x at the 0, is equal to 40 plus 12 into 2 minus 2 cube, which is 40 plus 24 minus 8. That comes out to be how much, sir, this one? 56. That means it has traveled a distance of x at the 2 seconds minus x at the 0, which is 56 minus 40. It has traveled only 16 meters. So this is our answer. Next one. A ball is thrown vertically upwards with the initial speed v. the distance covered by it in the last t seconds of its ascent. So what is the time of ascent formula? U by g, if I write it, and the initial velocity is going to be the u is equal to gt. I'll write it in this. Now, since it has been moving in the upward direction, distance covered, that means S is equal to ut minus u upwards positive, g negative minus half gt square. So that is h is equal to, if I put down the u value here, which is gt into t minus half gt square. So which is equal to the gt square minus half gt square. So 1 minus 1 by 2, it will be the half gt square. This is our relationship. Yes. Next one, motion of the particle is given by the equation. S is equal to 3t cube plus 7t square plus 14t plus 8 meters. So this is the thing, the value of the acceleration of the particle at t is equal to 1 second, he is asking. T is equal to 1 second. What is an acceleration? Differentiate for the velocity first. V is equal to ds by dt. So if I differentiate this relationship, what will I get? First case is, so it will be the 9t square plus 14t plus 14. Now when I go for the acceleration, A is equal to dv by dt. So that will be equal to the 18t plus 14. This is your acceleration value, and he is asking it 1 second. So A is equal to 18 into 1 plus 14. So 18 plus 14, that comes out to be some 32 meter per second square. So this should be your option. The position of the part x varies with the time. At x is equal to at square minus bt cube. Acceleration of the particle will be zero after time interval. So we need to get the acceleration. So we're gonna first get velocity v into dx by dt. That will be turn out as an 2at minus 3bt square. Next one, acceleration a is equal to dv by dt. So that is 2a minus 6bt. Acceleration should be equal to 0. So when this is equal to 0, 2a is equal to 6pt, and the time at which it has been happening, a by 3b. So this is the one he has asked. The acceleration of a particle is increasing linearly with the time as bt. So that means acceleration is proportional to or equal to the bt, if I write. The particle starts from the origin with an initial velocity v naught. Distance traveled is going to be how much? So acceleration can be written as an, I'm writing it as an dv by dt is equal to b into t. dv is equal to bt into dt. So integrate this one on the either side within the limits starting from initial velocity v naught to v at t is equal to 0 to t seconds. So this will be the v minus v naught is equal to, this will be the half b t square. From here, velocity v can be written as an v naught plus half b t square. But he is asking distance traveled there. So velocity can be written as an dx by dt. V is equal to dx by dt is equal to v naught plus half b t square. Take the dt to the other side. So from here, dx is equal to v naught into t plus, or x value integral of this one, that will be equal to the x is equal to, I'm directly writing the integral value. This is 1 by 6 into b t cube. So this should be your x value, or x is equal to vt plus 1 by 6 into bt cube. So this should be your option. Next one, the car accelerates from the rest. That means initial velocity u is equal to 0 at a constant rate alpha. Acceleration here is given after time t, after which it decelerates the constant beat. Final velocity is also zero. The total time lapse is t. That means at this initial velocity is equal to zero at a, and at the final point b, final velocity is also zero. But there is a two intervals are there where it is accelerating here with alpha, where here decelerating here. So let me take this point as a c, and the time for this one is equal to t1, and this is t2. So we see where you are reaching the maximum velocity. V maximum is equal to ut or u plus alpha into t1. Since u is equal to 0, t1 is equal to v maximum by alpha. Similar sort of equation if I write for the second case. Final velocity is equal to 0 is equal to, but it is starting from the maximum velocity deceleration minus beta t2, or from here t2 is equal to v maximum by beta, but the total time is t1 plus t2. Substitute the t1 and t2. So v maximum by alpha plus v maximum by beta is equal to t, and now find out the v maximum. From this one, v maximum is equal to alpha into beta by alpha plus beta of t. This should be your relationship. Yes. So now with this, we'll complete the today's session of the motion in a straight line. So it will be a very simple topic, and number of questions appearing will also be more. So please concentrate for the examination, and all the best to each and everyone. Thank you.